So the goal here is going to be to get some practice solving quadratic inequalities graphically. So we're going to solve the following equations and inequalities graphically. And the quadratic that we're given is negative x squared plus 2x plus 6. So we want to solve this when this quadratic is set equal to 2, less than or equal to 2, or greater than 2. Okay, so in Desmos, we're going to graph negative x squared plus 3x plus 6, and we're also going to graph y equal to 2, okay? And I want to show you graphically what's happening, how we solve that, how we want to think about it. All right, so I want to graph y equals negative x squared plus 3x plus 6. And I also want to graph y equal to 2. Okay. And I'm going to shift this a little bit so we're seeing the maximum of the parabola there. Okay, so when we're solving an equality, when we want to know when is the quadratic equivalent to this horizontal line of y equal to 2, we want to know what are those intersections, right? And if you click on the intersection, the point will stay there. It'll label it for you. Okay, so these two intersect at negative 1, 2, and at 4, 2. Okay, so we're going to use this information to answer the questions that we've been given. All right, so knowing that negative x squared plus 3x plus 6 is equal to 2 at both x equal negative 1 and x equal 4, then we know that the solution set is negative 1 and 4. Okay, so because those are the x values that make our equality true. Okay, a true statement. It's where they are equal. Okay, so in part B, when we're asked to solve negative x squared plus 3x plus 6 less than or equal to 2, so then we need to think about where is the parabola less, or I should say less than or equal to, that horizontal line at y equal to 2. Okay, so since it's less than or equal to, I'm going to say these are solid dots. I'm going to put the solid dots here in green, right at those intersection points. And I want to know, since we're being asked a less than or equal to question, where is the parabola, this quadratic function, below the line y equal to 2? Okay, so I just shaded in green the areas where the parabola is below the horizontal line of y equal to 2. And it happens in two places, right? Okay, so when that occurs, you're actually going to have two intervals in the solution set. So in interval notation, give me the domain of that piece I shaded. So it's going to be negative infinity up to negative 1, close bracket, right, since I'm including the point, in union with 4 to positive infinity. Okay, so then moving on to C, it says negative x squared plus 3x plus 6 is greater than 2. Okay, with strictly greater than, I'm looking for wherever the parabola is above the line y equal to 2. So where is this quadratic function of negative x squared plus 3x plus 6 above that line, right? Greater than. So since it's strictly greater than, I'm going to attempt to put open dots here in purple so we identify by color what we're talking about here. Okay, and anything above, so all of the pieces of this parabola that lie above, I'm going to shade it here in purple, above the line y equal to 2. Okay, I'll try to make that really clear there. Okay, does that make sense? So this is where the parabola is greater than 2, where its y values are bigger than y equal to 2. Okay, so what is the domain of that purple piece that I just shaded? Well, on the left end, it's going to be negative 1, right? We're not including the point since it's strictly greater than 2. And that's going to extend all the way to x equal 4, right? So we have the interval, open interval from negative 1 to 4. Very good. Okay, so that's the general idea. And also, just a reminder, Desmos does do this for you. So I'm getting rid of that line y equal to 2, and I'm just going to enter the whole inequality in at once. So if I say negative x squared plus 3x plus 6 less than or equal to 2, okay, notice the solid dots, and it gives me these two extremes. So from negative infinity up to negative 1, right? And from 4 out to positive infinity, yes? Okay, and if I change that to being strictly greater than 2, it gives me just the values between -1 and 4 with these open lines, right? Okay, but while this shades the appropriate region, it doesn't really show you how to solve it graphically, so to speak, okay? So make sure that you understand what's going on with the graph.